Hello guys, welcome back to my channel. So today we'll continue with the Eigrp route manipulation. So we already saw yesterday how when enabling passive interface on this router on all interfaces, okay, excepting gig 00 and gig 01, okay, that we're still able to see routes coming from R1, okay, as long as those routes were advertised. So if we check here, this we are on router 1. So this is the configuration of the router for routing. Okay, so Eigrp 150, that's the autonomous system. Then I advertise the loopback interfaces, and I also advertise the attached networks. Okay, and I set all interface to passive interface default. Okay, except gig 00 and gig 01. Okay, and the neighboring routers were able to see all the routes. Why? It's because the Eigrp multicast is running on this gig 00 and gig 01, and through Eigrp multicast and unicast, they're able to share those Eigrp routes. Okay, so if I go into R2, I should see all the routes coming from router 1. Okay, so show IP route Eigrp. Okay, so I not only see the route coming from router 1. Okay, this route coming from router 1. All these routes are coming from router 1. I also see the ones coming from router 5. Okay, these ones are coming from router 5. Okay, and now let's check the configuration of R2. So the routing configuration of router 2. Okay, so we see the same thing. We advertise the loopback interfaces. We also advertise the attached network. At this moment, only router 1 is attached. That's why I added only one network statement. Okay, we'll try to simplify it in the next videos. But instead of advertising everything, we're going to advertise it in a different way. We're going to see it on router 5, how it's advertised. And I set router 2 to also have passive interface defaults by default. So all interfaces. But what this means is that this statement means that router 2 will not participate in Eigrp except on interface gig 00. Okay, so that's what this statement means, because when passive interface default is enabled, what that means is that multicast and unicast is not going to be sent out on all interfaces. Okay, so it's going to be only on gig 00. And because of that, on router 5, we're able to see all the routes advertised by router 2. Okay, because that traffic is going through gig 00. Okay, this interface right here. So now if we go to router 5, if we go to router 5, and this router 5 here, let's show run router. Okay, so we're checking only the router, because everything else was already set yesterday, so the interface was all set. So how's the router? The router configuration is, I put the autonomy system 150. Okay, as I told you, if Eigrp router wants to participate in the neighbor updates and neighbor relationships, it has to have the same autonomous system like the other. Okay, so 150. And now the network statement is what's interesting here. Okay, so instead of advertising every single subnet, okay, I just put network 0.0.0.0. Okay, that way we're saying all networks attached to this router 5 will participate in Eigrp. Okay, but the next statement, passive interface default, says none of those, this router is not going to participate in Eigrp except through interface gig 00. Okay, So what that means is that the routes, these routes that were advertised, okay, all the routes advertised here, they're going to be sent out through this interface. Okay, so it's in industry, it's a more standard way of configuring. Okay, where you advertise, you set the the interface that would not be able to send update to other routers. Those interfaces must have a passive interface default enabled. So yeah, so with that in mind, if we go into router, let's check what router 5 has. So IP route Eigrp. Okay, so see router 5 has all the routes. Okay, you can see all the routes coming from router 1 and router 2. Okay. All right. So anyways, that was just to prove that point that actually we didn't need to we need to on all these routers we can actually advertise on the passive interface. We can set those routers to passive interface default, except the interfaces that actually are linked to other routers. Okay, so that's the purpose of this particular example I was trying to show. Now, for today, we're going to do route summarization. Okay, so we're going to do route summarization between router 4 and router 6. So what we're going to do is we're going to first enable Eigrp on router 4 and router 6. We're going to see what routes router 4 and router 6 are seeing. And then we're going to make sure that we can reduce the routing table of router 6, okay, for routes, for the loopback interfaces, routes coming from router 4, okay. So let's get into it. We're going to power this thing on. Okay, now that's powered on. We can now open it. All right, so router 4 and router 6 are up, okay, but there's something configured in them. Okay, so if I do show IP interface brief on router 4, there's nothing configured. If I do the same thing on router 6, show IP interface brief. Okay, so what I'm going to do right now, the interfaces, some of them are showing up just because they are already connected. They are connected even though they cannot, they're not reachable. So I'm going to just this the way I did for the other routers. Okay, so this is the interface configuration for router 4. Okay, it's the exact same thing that we have here. It's the exact same thing we have here, except that I added also the router ID. Router 4 router ID is 10.4.4.4. Okay, for loopback 0. Apart from that, everything else is exactly this. I'm just going to copy paste, okay, for the interfaces, because I assume that this is like you don't. I mean, you can do this by yourself. Interface calculation, interface configuration of the router. That's the basic. So I'm just going to copy and paste. Okay. And then I'm going to save just in case I forget. I'm going to do exactly the same thing on router 6. Okay. So router 6, these are the interface for router 6. Okay. With this router ID, I'll just double check. Okay, router 6 is 206.66. Okay, 206.66. Those are the loopback interface. 206.66. So it's the same thing. I'm just going to copy, paste on router 6. Okay, and I'm going to save. Now that the interface configuration is done, we could actually do show IP interface brief router 6, so that our interfaces are all up. And then also we do the same thing for router 4. So IP interface brief. So all those interfaces are there. So what's left right now is to enable EIGRP on router 1, on router 4, and router 6. Okay. So now I'm going to do it a little bit differently. Okay. I'm going to say on router 4, I'm going to say configure terminal router EIGRP 150. Okay, I'm saying I'm going to do it a little bit differently, but actually we've seen that already on router 5. Okay, how we configured EIGRP on router 5, that's how we're going to do it on router 4 and 6. So, so I'm going to say no auto summary. Okay, that's very important. And then next thing, I'm going to say network 0, okay. I don't need that. What that means is that anything attached to anything attached, any network interface configuration attached to this router 4 will participate in EIGRP route EIGRP 150. Okay, that's what that means. Now I'm also going to set this. I'm going to enable passive interface default. Okay, on this router, accepting the routers, the interface that we want to participate. Okay, so I'm going to say passive interface default. Okay, and I'm also going to say no passive interface here. Okay, so right now we don't care about this because in any case this router is down, so we only want to enable for this link. Okay, so no passive interface gig 01. So no passive interface gig 01. Okay, and with that, our configuration is done on router 4. Okay, I'm gonna save. Do the exact same thing on router 6. Configure terminal. Okay, router EIGRP 150. No auto summary. Okay, network. All networks attached to this router 6 will participate. So 0.0.0.0. Okay, and I will say passive interface default. Okay, none of those interfaces going to participate in EIGRP except no passive interface gig 001. Okay, I think 00. So only this gig 00 will participate in EIGRP. Okay, why? Because as I said, it has enable running EIGRP, so this interface has to be up. Okay, so I say no passive interface gig 00. Okay, and then save. Okay, so after saving, if I do show IP route EIGRP, okay, we see we're getting all the routes coming from the from router 4, the loopback interface routes router 4, and also we have the router ID. So basically, we just have routes coming from router 4, okay? Because as I said, we don't have this. We doesn't have. We didn't enable EIGRP here, by the way. Okay, we'll do that subsequently if we have to. So we only have routes coming from either the loopback interface or the routes that are directly attached. Okay. So in the same way, we go to our router 4. We will show IP route EIGRP. Okay. So these are the routes coming from the loopback interface of router 6. Okay. All right. So now let's get into the fun part of it, which means let's go here. So what we want is for this tutorial, okay, we have a small routing table, but in reality, in real life, sometimes a routing table can be really, really big, and it's in our interest to make sure the routing table is readable, because it's very big. It means you have take more time to actually sort out what routes are on that table. So it's in our interest sometimes to summarize the routes. So we're going to do manual summarization. So the way it's going to work is that we want to see the on router 6, those loopback interface routes from router 4 summarized. We don't want to see every single route. We want to see a summarized route from this loopback interface. So now we're going to this is where we have to basically check exactly how those networks are advertised. Okay, so we have so we want to summarize it 204.44, okay, dot 4.4, 204.44.5.4, 204.44.6.4, and 204.44.7.4. Okay, so to summarize, we're going to first of all find out what are the bits that are common. Okay, so if we take this as an example, we're going to say here, so we have 204.44.4. Okay, let's just say dot 0, okay, because the bits are changing. So it's going to be dot 5, dot 0, dot 6, dot 0, 7, dot 0. So everything here is the same, okay, it's the same here. So the only thing changing is here. So already what that means is what is 4 in binary. Okay, so we have 4, 5, 6, 7. So what is 4? 4 in binary. 4 in binary is 1, 0, 0. Okay, 5 is 1, 0, 1. 6 is 1, 1, 0. 7 is 1, 1, 1. So from what we see, okay, again, this one is not changing. Only the last 2 bits are changing. And if that's the case, then our summary route is actually 204.44.4.0. Okay, that's our summary routes. Okay, so that's exactly what we're going to put on the on that's how we're going to summarize our route. Okay, so this is going to be the network address. Now, how about the subnet mask? Okay, how about the subnet mask corresponding to this address? So the way the subnet mask calculated, we have we're going to calculate it only for the third octet here. Okay, the third octet has to be, remember we said 100 was a summarized third octet. Okay, it's 100, which means instead of 4, 5, 6, 7, it's going to be just 100. So which means the bit that did not change for the third octet only is going to be 1, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, this is only the third octet. Okay, only for this one. Okay, so because the reason we call it octet is because there are 8 bits on this port. Okay, so there are 8 bits there, there are 8 bits here, there are 8 bits here. Okay, that make up this number. So for this third octet, there are 8 bits, and 2 of those bits are 0 zeros, and the other bits are unchanged. If you see a 1, it means that it's unchanged. And to calculate the subnet mask, for the first one, you're going to calculate, it's going to be equivalent to 128, okay, times 1 times 128 plus 64, okay, Let me do it to my. All right. Okay. Okay. So plus 64 plus 32. Okay. 1 times 32 plus 16 plus 8 plus 4. So each of these positions, okay, we have 128 here, we have 64, we have 32, we have 16, we have 8, we have 4. We actually have 2 here and 1, okay, but actually since they are zeros, if you multiply, it's going to be 0 and 0. So 4 times 1 gives 4, 4 times 8 gives 8, 4 times, sorry, 8 times 1 gives 8, 16 times 1 gives 16. So it's going to be plus, 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 okay. So if you sum everything, this gives 252, okay. So our subnet mask is going to be 255.255.255.252, okay. This one, dot 0, okay. This 0 here was unchanged. The last octet was unchanged, so dot 0 here. So that's going to be our subnet mask. Now, how do we apply it? We're going to apply it per interface. So we're going to apply it per interface. I'm going to just delete this. So we don't want these routes appearing on this router routing table. So we're going to apply it on this interface, gig 001 of router 4. Okay. So let's go into gig 01 of router 4. Configure terminal interface gig 0-1. Okay. And then we're going to say IP summary address Eigrp 150, and then we'll give the, if we say question mark, we'll ask for the summary IP address. The summary IP address is 204.4.4.0. Okay. Now it's going to ask the network mask, as we just calculated, is 255.255.252.0. Okay. So 252 is calculated from, is a summarized network address. Okay. Oh shit. Let's see. I think there's something. I need to basically check what I configured. Okay. So yeah, so this is the configuration that we're going to put on the gig 01 of router 4. Okay. IP summary address Eigrp 150 204.44.4.0 for that subnet mask. Okay. And we say enter. We say enter. Then we save. Now let's go to R6 and see what's different. Okay. Let's go to R6 and see what we're getting from there. See, you see there's an update here. So I'm gonna do IP route Eigrp. So these are the summarized route. You can see right now we have, previously we had a bunch of routes coming from the loopback interface of router 4. Now we have just one summarized route. Okay. So our summarization works. So we're going to stop here because I don't want to make these videos very long. I know it's already long, but I want to stop right here. So you can see that our routes are being summarized effectively. And in the next video, I'm going to show you how we could enable Eigrp route leaking. What that means is that if we have interfaces that have different bandwidth and different speeds, like this one, we have 128 meg, okay, linking directly R2 and R3. And then we have 1544, okay, higher bandwidth, linking R2 and R7. Also have higher bandwidth, 1544, linking R7 and R3. We want to make sure that our traffic goes this way because it's a faster link, okay? Instead of this way, this is a slow link. So how do we do that? That's going to be the subject of our next video. And for now, if you haven't watched the other previous videos, please do check those other videos. And so thanks so much for watching, and talk to you in the next video.